Yuri Sidor, post news, also on OnlyFans site also. There are no ads there. Laughing face emoji. Thank you for your suggestion of posting my videos on OnlyFans. You know, like, I make comments, concerns, questions. I have issues with YouTube. And whenever I do, people will say, okay, well, why don't you use this other platform? And they'll recommend me streaming on Twitch. They'll recommend me going deeper. They'll recommend me going deeper into the YouTube ecosystem, setting up memberships, channel shoutouts, putting ads in the middle of the videos. And I've had recommendations for OnlyFans. And like, I have no prudish reason why I wouldn't post my videos on OnlyFans. The problem is just the commission. So, you know, we always talk about how we put our videos over on Patreon. And I mean, there's a bunch of reasons. Like, I really like Patreon as a platform. They're doing a lot of work to make Patreon a better platform. But I have been on Patreon since 2014. Is that right? 2013, 2014? Early on, like within the first 6 months of when they set up Patreon. And so I am part of the legacy account on Patreon. And so they only take a 5% commission of all of the revenue that we make from the viewers. So we keep 95%. Patreon takes 5%. And when you think about like what it would cost for just like, if you just wanted to roll your own membership system using Stripe, it's 2.9% plus 30 cents a transaction. And so you actually would kind of lose money compared to Patreon, because Patreon bundles up the pledges and then processes them in one big block. So it's actually almost a better deal. And then you don't have to deal with all the hassles of returns and updating your accounting software because Europe has a new tax. So OnlyFans takes 20%, which is not bad when you like, that is, of all of the other platforms that are out there, OnlyFans is, 20% is not bad. And, you know, you don't have to have racy content on your OnlyFans site. You can put whatever content you want. And so if you don't get accepted in Patreon for whatever reason, then that sounds like a perfectly reasonable approach. And then it gets worse. So Twitch typically takes half of your channel membership. So you take half, Twitch takes half. And I don't even know what the ad split is. I've never even bothered. Like, I have a verified account on Twitch. I'm a partner on Twitch, and I don't think I've even used it. I really should. I should like stream on both YouTube and on Twitch, but I just don't. Cause I just can't be hassled. And then YouTube is kind of the worst. So, for the ads, YouTube takes half, roughly half. And then for the channel memberships, I think they take 30% and then they give you 70%, which, you know, again, is not as good as Patreon. And you're locking yourself into a platform that, you know, has an algorithm that controls your interaction with your audience, which on Patreon and with OnlyFans, you have the direct connection to your audience. So that is always going to be the preferable way to go about it. People recommend Nebula. And I love Nebula. Like, I think Nebula is a fantastic idea, but Nebula is a paywall. So you pay for Nebula and then you get access to all of this creator content, which is incredible. And it's a great way for the creators to get paid. For me, I want my content to be available free without ads for as many people as possible. And so with Patreon, then we don't put any ads on anything and we don't put it behind a paywall. Everything is just free. As much as, you know, except for some of the patron-only content that we create. So yeah, I am completely agnostic about the platforms that we go on. I will gladly take on new platforms if it looks like it's going to work for us. The things that matter to me is a direct connection with the audience, so that I can reach out and let the audience know if things are happening, and a reasonable, fair split in revenue between me and the platform. YouTube is great because it's a discovery engine. YouTube is the second largest search engine on earth after Google. And so we get a ton of new people finding out about us on YouTube. And so the other platforms, if Twitch had good discovery, if OnlyFans had good discovery, then I would absolutely use those other platforms as well. So it's discovery, it is direct connection with the audience, and it is the cut. Okay, that was the zinger first question to get people excited about the channel, or the live stream. And so now we move into the regularly scheduled programming for this this question show. So what is it that you have stumbled into? This is a 2-hour live recording of me answering questions from the audience. I have no idea what you're going to ask. This is AI-able. I guess it's pretty AI-able. There are AI VTubers at this point, aren't there? Forget it. I take it all back. I am eminently duplicatable by AI, or I will be very soon. But you know, but I'm real. I promise, which is exactly what an AI would say. Okay. Anyway, so a few ground rules. I try to give emphasis to the people who've never had a question answered before. So if this is your first time here, I really like your chances. I am a journalist, not a scientist. And so if you want to ask me my opinion about some scientific theory, I do not have one. And I know a lot of you find that enraging, and I'm sorry, I don't have one. I trust and believe in the scientific consensus. It is the best way. You get a whole bunch of scientists to agree. That is the best way to know if something is most likely to be true. Now, obviously, it doesn't mean that it's true, but it is most likely compared to all the other ways, like that thing that your crazy uncle told you, or that channel on YouTube that popped up and is telling you that something is an alien spaceship, right? Ask 1,000 scientists whether that thing is an alien spaceship. And if they agree that it is, then that is the scientific consensus. And that's what I'm going with. But if they are skeptical, then I will also be skeptical. And the last thing is we get a lot of the same kind of questions. Do you believe in aliens? What's the great attractor? So I may skip your question. It's nothing personal. It's just that we get that question a lot. So yeah, let's get cracking. Oh, and a huge shout out to Zapvan. We seem to be rolling on the new system again. Things seem stable, but stay frosty if it breaks. Thanks for showing up. Okay, let me see what we got. Ashstar, do we not do the color panel anymore? We did. I did it. I did it like right at the beginning when I recorded. There's a second one for you. But now the color changed because I've had your question up on my screen. Known unknown. Hey, Fraser, can you tell us any information about the interactions between neutrinos and dark matter? So I don't know. Is there new news on this? I just want to make sure that there isn't like a new discovery that I should be aware of. January 7th. Oh, right. Yeah, we did record this. Okay, hold on. Let me get a good answer for you here. Okay, all right. Okay. So dark matter, of course, is this ongoing mystery about the universe. Why do galaxies rotate too quickly? Why do we see this gravitational lensing of light as it's passing from distant regions of the universe to us? Why do we see sort of concentrations in the cosmic microwave background radiation? There's a bunch of these observations that astronomers have collectively gathered together and called dark matter. And as always, dark matter could be matter. Dark matter could be that we don't understand gravity. Dark matter could be that the models are wrong. Dark matter could be that the observations are incorrect. Like don't get too hung up on the word dark matter. And so when dark matter was first discovered, in 1936 by Fritz Zwicky, astronomers had no idea. Like they said, okay, maybe there's some kind of extra mass and maybe gravity doesn't work the way we think. And there was this hypothetical particle called a neutrino. And since then, neutrinos have been discovered. And neutrinos are very similar to what dark matter would be like. we always talk about how that there are hundreds of billions of neutrinos passing through your body at all times, just coming from the sun, and you don't feel them. They don't interact with your body in any way. It's only when you build a giant detector a kilometer across, in Antarctica or in an ocean, and you put detectors all through this area, you detect the occasional interaction with a neutrino hitting a molecule of water. But it doesn't happen very often when you think about that. And they always say, a neutrino could travel through a light year of lead and not interact with any of the protons in the lead. So neutrinos have mass, probably. They follow the distortions of space-time, so they probably have gravity. And even if they don't have mass, they would have gravity due to the E equals mc squared, right? The energy equivalent for their mass. So if you just had enough neutrinos, then that would be dark matter. And this was a very seriously considered solution to the problem. But the problem is that the characteristics of whatever dark matter is, it has to be moving very slowly. And neutrinos move close to the speed of light. And so they have been ruled out as an explanation for dark matter. You're left with something that has a lot of the same characteristics as neutrinos, but are very slow moving. And so that's why, like, one of the ideas is a thing called a sterile neutrino. But there's other possible particles to explain that sort of missing mass. You detect the gravity, but you don't detect the stuff that is causing the gravity. But earlier this year, astronomers were thinking about because there is so much dark matter, and because neutrinos are everywhere and they're going through everything, would there be some kind of interaction between neutrinos and dark matter? And if so, how would you be able to tell? And so in this paper that came out in January, and we reported this on Universe Today, the idea is that when you have galaxies that are out there in space, they are distorting space-time with their gravity. And you get what's called a shear, when you think about sort of like the refraction of light, when light sort of moves through a medium and it sort of gets bent, right? So you imagine the sort of the effect of that gravity is going to cause a sort of shear on the gravitational lensing, on the space-time around it. And you're going to get this distortion of the light that's coming from a more distant region. And so, according to the scientists, and I don't fully understand this, that if the neutrinos are interacting with dark matter around a galaxy, a dark galaxy is much bigger than what we see. We see the stars in the galaxy, but we don't see the giant cloud of dark matter that surrounds it. And the neutrinos are going to be blasting through that, and they're going to be essentially changing the way the gravitational lensing appears at a level that is potentially detectable by the new generation of telescopes that are measuring gravitational lensing. And so, in theory, if neutrinos interact with dark matter, then we should be able to detect it in the large gravitational lensing being done by Euclid and Nancy Grace Roman. So stay tuned for that. Ashstar, how do you stay motivated when the world seems to be turning its back on progress? I've been pretty clear that I am frustrated and a little puzzled and kind of obsessed with what I'm seeing as a pushback on really just expertise in general. And the cause of it, the heart of it, is a very cynical thing. We have seen that it is very profitable to get people to distrust scientists. People are going to be watching this video, and I'm going to say global warming is happening, right? Climate change is real. I'm going to say that COVID vaccines were effective. Then that there is like a lot of people that makes them really angry, and that there was a lot of work being done, a lot of disinformation put out on social media platforms, put out on alternative news channels, YouTube, that kind of thing, to get people riled up. about science. And, that, you see a ton of the comments, the YouTube comments on my channel and all of the science YouTubers where, dark matter is like a religion and scientists just don't know what they're talking about. It's a fudge that they've done to make up something. And you don't understand dark matter, right? Evolution is and a lot of it is religiously motivated. And so you can kind of trace it back to various theologians, various people who are attempting to bring down science and offer up their religious beliefs as an alternative to science. And so since science is so effective, since science gets the job done, you've got to set up a pretty big straw man to be able to kind of tear down scientists in the minds of the people who are watching you. And I think as well, people don't like someone to say that they're an expert in something. It rankles them, bothers them. And yet, at the time of our greatest need, when we are sick with cancer or something like that, we will go see the doctor, and the doctor will recommend that we follow a treatment, and then we will do the treatment, and we will be cured or not. And so when the stakes feel like they're low, or the stakes feel like things are uncertain, then there's a distrust in science. And it drives me bananas, for sure. Because science, once you know how science works, that it is very skeptical by default, that it is like Thunderdome, that scientists are constantly battling with each other, that anybody who doesn't do enough work to provide evidence for their theories, doesn't show their work, does sloppy math, bad statistics, they get found out in the end, or you hope so. And it's other scientists that are calling them out because they have the expertise to recognize. And yet we live in this world with computers and internet and airplanes that fly and fancy metamaterials, and because of scientific progress, right? We rely on it. And so we live in this really weird place where we rely on scientific progress for our lives, for the quality of our lives. And yet that there are moneyed institutions, that there are giant oligopolies, that there are people who are paying money to make people distrust science so that they can make more profit. Right? Distrust climate change so that you'll buy more so people will stop regulating oil and fossil fuels, right? And people are falling for it. And I think it is gone beyond what the people who were trying to make people distrust science had hoped for. Right? They were yeah, get people to have questions about whether or not they should buy an electric car versus an internal combustion engine car. And suddenly people aren't taking their measles vaccines, right? You're I don't think that's what they expected when they were trying to sow distrust in science, but that's what you get because if it bleeds, it leads. And so on social media, if people are making these outrageous claims, then people will, that gets more engagement. People will check it out. If people are being awful to each other in the comments, then will get more engagement. And then that will drive more people to look at it. And people will pick their side and pull out their pitchforks and start jabbing at each other. And it sucks. And I hate it. And if you've I'm sure you all have that crazy uncle in your life who has a lot of bad opinions, ill-formed opinions, right? They're ignorant and has little tolerance for you attempting to provide some kind of evidence and rationality and reason in response. Those methods, let's agree on a common set of facts. Let's deduce step by step what is the correct result for this. And And if you've ever experienced just like having a person in your life that you were trying to have a reasonable and rational conversation with, it's really hard to do and essentially impossible. And so it's like an event horizon, right, around a black hole. And each one of these people who has been swayed by big conspiracy has fallen over the event horizon, and you can almost never bring them back. And so I had a call with a patron today, and he was saying that I was like browsing on YouTube and I was seeing a lot of videos about Comet 3i Atlas and making all kinds of outrageous claims and a lot of other stuff. And then I found your video about 3i Atlas, and you just sort of explained the science. And then I watched your video, and then I watched another one of your video, and I realized that I was kind of pulling myself out. I was dragging myself out of a kind of conspiracy rabbit hole. And it filled me with hope that I was able to influence a person to kind of come back to the side of science and rationality and reason. But it was like, what are the chances? Like, how many people get a chance to do that? It's rough. And so most of them are going to be on the other side of the event horizon. And once you stop believing in a common truth, like just facts, then it's dangerous, because people can justify their actions based on a discordant set of facts. We did this because this is true. We did that because that is true. And both people are saying this thing is true, but neither one is right, or one of them is correct and the other one is just lying, or is thinking they're doing something because somebody else lied to them. And I don't know the way out. I mean, it's interesting. Like, I know Hank Green has been doing sort of a series and thinking about the same thing ideas out loud. Other people have been concerned about this as well. And I don't know what the answer is. And the consequences are bad, right? In terms of the new technologies and the state of nuclear weapons and artificial intelligence and viruses and various economic issues. Like we are, the issues that humanity is facing are getting more complicated, more difficult, and require a higher ability to work together at a time where we are falling further and further apart. So it is definitely frustrating and troubling. So, like, what can I do? I just show up and I just explain science, and I answer questions as patiently as I can, time after time after time after time, and hope that I am able to influence people one at a time to open their mind to how interesting science is, and to understand the scientific process, and to use these methodologies of being skeptical and critical thinking and reason, and use this in your day-to-day. And when someone tells you something, have that moment to go, wait a minute, that seems fishy to me. Let's look it up. Let's find the paper. Let's discuss this, and push back. So like, how do I stay motivated? Like, I don't know, like, it's a big problem and I feel like I have to do my part. So that's what motivates me, is I show up and I do it. And I hope it's going to get better, but it doesn't seem to be getting better, which sucks. Will Stack, we have to overcome the rocket equation to viably travel interstellar space. Is there an antimatter equation that would show a specific impulse delta V for, say, a proposed visit to Proxima C? So, all right. So, let's start this. Okay. Stars are really far away, and we want to be able to travel to another star system in a human lifetime, if possible. In fact, we want to travel really quickly. I'm rewatching Stargate right now, and you want to just walk through the gate and come out on the other side on this other planet. That would be ideal, but warp drives would be fine. The hyperdrive in Star Wars, also fine. But right now, this incredible distance, all we have are chemical rockets. This sucks. And our current chemical propulsion systems can carry us to other stars. The Voyagers are on an escape trajectory out of the solar system, it'll just take them about 50,000 years to reach the nearest star system, say Proxima Centauri. And when engineers have looked at all of the options that we have available to us as ways of propulsion, you look at ion engines, not fast enough. You look at even fission rockets, not fast enough. That there's really only two viable ways to be able to get to another star system. One is that you don't carry any propellant on board your spacecraft, that you are hitting a solar sail with a powerful laser or a series of lasers that are imparting energy, momentum to the spacecraft that allow it to cross the distances. And people have proposed that a laser sail could be accelerated within the solar system to, say, 10% the speed of light, and then it would take 40 years to get to Proxima Centauri. Wouldn't be able to slow down, so that's a whole other challenge. But if maybe eventually you can imagine some far future where we've got a series of big lasers in the solar system, and then a series of big lasers at Proxima Centauri, and then laser sails go down this virtual chute where the lasers speed them up and speed them up and speed them up, and then they coast from the sun to Proxima Centauri, and then the lasers on the other side shoot and shoot and shoot and slow these things down and put them into orbit around the planet at Proxima Centauri. That'd be cool. The other method is you carry propellant on board, but it is the most energy dense propellant that has ever been, that is really possible. The only energy, the densest energy source imaginable is antimatter. And so you take antimatter, you take matter, you combine them, and you get pure gamma ray energy, which you can then harness. You can fire the photons out the back of the rocket. You can use that to heat up some kind of propellant and be able to fire that out the back of the rocket. Antimatter is the way. But antimatter is incredibly expensive. I'm not sure sort of if the costs have come down, but last time I looked into it, it was like $65 trillion an ounce. No, a gram. So last time I looked, it was like $65 trillion per gram for antimatter. And you would need a few kilograms to get to rapid velocities, more. So we just don't have the antimatter production on Earth to be able to handle it. Could it work? Yeah, absolutely. Antimatter is the thing that if we put a huge amount of the world's energy production into making antimatter and then storing that antimatter and then putting that onto a spacecraft, we could accelerate a spacecraft to relativistic speeds and then slow it back down again. And that's the key, to be able to slow it back down again. And so if you haven't already read Project Hail Mary, that's kind of what they did in Project Hail Mary. But the movie's coming out in March, so you'll be able to watch sort of what it would be like for the world to be throwing a huge amount of its energy into antimatter production to be able, or something like antimatter production, to be able to allow a mission to be able to fly to another star system. So, I don't have I can't do the math, but is there a specific impulse delta V? Yes. You can calculate the power of an antimatter rocket. Glenn Scott Harris, do you know where the moon mission progress is at? So we posted Space Bites on Thursday, and we recorded Space Bites on Thursday, and that was when they were going through this process of doing a wet, oh man, what do they call it? Anyway, they were doing the full test of the Artemis mission. Why am I having trouble? Someone in the chat. That's crazy. Anyway, okay. So on Thursday, they were doing a sort of test of the entire Artemis 2 mission. So they were filling up the Space Launch System with the hydrogen and oxygen, tanking it up, and getting to the point... they go, wet dress rehearsal. Yeah, all right. Getting to the point where they would then do the countdown and demonstrate that the rocket was ready to go. And they would stop the countdown just moments before they actually launched. And so they went through this wet dress rehearsal, and got down to the point where they were happy with it, and then realized that there was some more problems with the rocket, and the problems can't be fixed on the pad. And so they're going to have to take Artemis back to the vehicle assembly building, the Space Launch System, fix these issues back at the VAB before they can then deploy it. And so now the March launch is out. And so now we're probably looking at April for an actual launch of the Space Launch System for Artemis 2. And I feel like I called this, that don't be surprised if we're going to have to wait months for this to actually get off the ground. This is, this is the one with all the marbles. This is the one with humans on board. They're not going to take any chances. How many people do we have tonight? Okay. Just Chris, do we know if there's any more or less radiation in areas that we suspect that have more dark matter? So there doesn't seem to be any indication that there's more or less radiation coming from areas where there is suspected to be dark matter. Like, we know where the dark matter is. You can do gravitational lensing to be able to see the distortions of light around galaxies, and that allows you to map out where the dark matter is. And in this way, astronomers have found entire galaxies that have almost no regular matter in them, just dark matter. You can just see this blob of distorting space where there's just a big blob of dark matter. But there's like a potential indication of an excess in energy, and that's from the center of the Milky Way. So for a long time, astronomers have known that there's an excess of gamma radiation that is coming from the center of the Milky Way. And one explanation is that dark matter is falling down to the center of the Milky Way around the supermassive black hole, concentrating and getting so close to itself that it is annihilating, that you've got particles of dark matter, whatever they are annihilating with each other, and then they are producing this gamma radiation that we are detecting in excess. And this is considered sort of like one of the best lines of evidence that there is some kind of accumulation of dark matter at the center of the Milky Way. However, there have been plenty of other explanations for this excess of gamma radiation. For example, there's a lot of pulsars at the center of the Milky Way. Pulsars have these really powerful magnetic fields around them. Magnetic fields can generate antimatter just spontaneously. And then the antimatter finds matter, produces gamma rays. And so that's another perfectly reasonable explanation. And of course, whenever you've got something extreme, like a supermassive black hole, you can just blame almost anything on that supermassive black hole. So maybe there's some interaction between the black hole and matter around it that is producing gamma radiation that is causing an excess. So, but yeah, but people have thought about this. Stanton, how quickly do you believe the robots will give us Jetsons reality? Have you seen the tech demo of the Chinese robots at it was the Chinese New Year, so just a couple of weeks ago, and they were doing kung fu, and they were doing backflips, and they were doing wall climbing, and it was absolutely incredible. And you can then kind of look and see people have done retrospectives of what their mobility was 1 year ago. And they were just like making these very simple hand gestures. It was not that impressive. And now 1 year later, these things are just doing incredible flips. Imagine where they're going to be the year after that. So at this point, they've got the mobility down. They are powered and autonomous. And now it's about the training. And I've seen plenty of examples of people training robots on washing the dishes, putting away laundry, doing various chores and tasks and things like that. So if you'd asked me like a year ago, I would have said probably 20 years. And now the mobility is there, the flexibility. And so I think the robots that are able to do various tasks are coming more quickly. And then, of course, use robots to make other robots. And so hopefully it'll bring the prices down. So in the near term, you're going to be looking at tens of thousands of dollars to buy a robot that will poorly wash your dishes. And, for those kids out there, that's, you know what it was like. That's your job, right? I don't know, my parents, always used to ask my parents why they didn't buy a dishwasher. And they said, we have one. It's you. And then when I moved out, they bought a dishwasher. But anyway, I digress. So I think that we are now, with the sort of the rise of large language models as the intelligence layer of this, as well as all of the training that's going on and the mobility of those robots, I think this technology is going to come pretty quick at this point. It's probably going to be out of reach for most people for a while, but the way this technology works, prices come down, things get cheaper, that I think we will probably all have robots in our house at some point, or maybe the rich will have them in their house. Were the Jetsons rich? No, they were like middle-class people. So I would say not too long at this point, a couple of years, we will see commercially available home robots that don't suck. Ed Skeptic, Y2. Ed Skeptic, who's the most credible AI dead scientist narrator on YouTube? So yeah, like if you go and you look on YouTube, there are a lot of YouTube channels that are just digging up Feynman, Einstein, and then living ones, Brian Cox, Michio Kaku, Neil deGrasse Tyson, and they're just running roughshod. And then I've seen this is happening in other fields as well. So you have economists, you have philosophers, things like that. And people are just making videos based on what they might sound like and look like and would write like. And YouTube is not doing anything about it. There was I saw a Richard Feynman video, a fake Richard Feynman video that had gotten 3 million views. I would love 3 million views. I've never had a video that's had 3 million views. That's crazy. So clearly the solution is just steal the likeness and voice of somebody and ka-ching ka-ching. Oh, I missed it, but there's like a great big fight in the chat about people not trusting science. So I believe that's what I predicted. Let's see. Okay. Dartman X. If the safe zone for a type 2 supernova is 50 to 100 light years, what is the safe distance for a type 1a supernova, a white dwarf supernova? Yeah, the safe zone, the suggested safe zone for supernova kind of changes over time. And so I've seen plenty of estimates. Typically, it's in the 30 light years away to 200 light years away is the safe zone just for supernovae in general. And the risk, the danger, like if you're really close to a supernova, then you just take this straight up blast of radiation that's going to hit your planet. But once you're farther away, the risk is that the radiation that comes from the supernova strips away the ozone in your atmosphere. And so it lets in more radiation, and so everybody gets more cancer. And that could lead, or has theoretically led to extinction events in the past. Although not as bad as whatever were the true great extinction events. We believe, or geologists have found evidence of fairly recent supernovae that went off in our vicinity in that kind of, 100-ish light years away range. They found isotopes of iron at the bottom of the ocean. And so one was like 6 million years ago and one was like 11 million years ago. And so clearly the Earth was hit by a supernova, that some of the radiation hit the atmosphere, but we also have the actual particles that made it to Earth, which is kind of amazing. So Type 1a supernovae are more powerful than your kind of bog standard supernova. And so, sort of estimates at about 50%. You want them to be about 50% farther than you want a regular supernova. But again, like I said, the ranges for what's safe and what's dangerous change depending on what is the most recent scientific paper. The ones that are really scary are the gamma ray bursts, because those can reach out and impact your planet from halfway across the galaxy. That you could have one that is 100,000 plus light years away, and it could still strip away the ozone out of the atmosphere of your planet. So the example that I was like is that there was a gamma ray burst that hit the Earth, that it came from another galaxy tens of millions of light years away, and it caused the atmosphere to wobble when the gamma ray burst hit us. So gamma ray bursts are next level. There are no stars that have the potential to go supernova in that dangerous vicinity. There are no stars that are thought to be able to go gamma ray burst with the jets pointed at us, again, within a reasonable vicinity. There was a Wolf-Rayet star that was kind of close, and people were a little concerned because it did seem like the pole was sort of pointing at us, but now we know that it's not. And so right now there are no dangerous looking supernova or gamma ray burst progenitors in our vicinity. Johnny Appleseed. How much do 3 million views pay? You make about $5 per 1,000 views. So $15,000 ish US. It could be $10,000 to $20,000 for that one video. We select you. What are the plans for the next International Space Station? Will it be private only? Yeah, so the International Space Station is due for deorbit before 2030 and probably 2028, but maybe 2030. And if it doesn't get deorbited, the Russians are expecting to detach their chunk of the station away from the main International Space Station. So whatever happens, by the end of the decade, the ISS is going to come down. The plan is to launch the Deep Space Gateway, the Lunar Gateway, as the replacement for the International Space Station. So astronauts will fly up to the moon, essentially be in orbit near the moon, and then be able to transfer from the Lunar Gateway down to the surface of the moon and back. The Trump administration has been trying to cancel the Gateway. Congress has sort of refunded it, not refunded it, but continued its funding. And so that is the plan. So right now, Artemis 2 is going to be the flyby around the moon. Artemis 3 is going to be people landing on the moon. The construction of the Deep Space Gateway will probably start around Artemis 4. So probably nearing the end of the decade, 28, 30, we should see the first module of the Deep Space Gateway become operational. But the United States will have no working space station in low Earth orbit. So the only one is going to be the Chinese space station. That said, there are a bunch of private companies. The one that seems furthest along is a company called VAST. And they've got a really cool design. They've got this sort of modular design where they can just kind of add more modules and grow the space station kind of indefinitely, just sort of like this big disk that just gets bigger and bigger with more modules. So hopefully we'll see the vast station launch before the International Space Station comes down. But right now, I always say that, private space exploration is a very expensive business and there's not a lot of return on investment. And so any company that goes into this could lose everything. It could go bankrupt. And so really launching a large space station requires the resources of a country or a collaboration, an international collaboration of countries. Knit Styles. I get confused with gravitational lensing. If we were to reach the gravitational lensing point of the sun, what would we see? Would we only see objects directly behind the sun magnified? Right. So this is the solar gravitational lens, which is located about 550 astronomical units away from the sun. So you've got the sun. The sun's gravity is acting like a natural telescope lens. We know that gravity distorts space-time. And so as photons are going around the sun, and they would be heading off into space, the gravity of the sun bends them back and focuses them at that point, 550 AU. So what would you see? Well, it would look very similar to traditional gravitational lenses, where you have a foreground galaxy cluster that is lensing some background galaxy, and the galaxy has been turned into this kind of mushed arc that is around the galaxy. And sort of the most perfect ones are called an Einstein ring, where you actually get the central galaxy cluster that's providing the gravity, and then you get this ring that is around the galaxies. There aren't a lot of them, but they're really cool and they're very useful when astronomers find them. And so the light from this galaxy that would be pretty much invisible has been magnified by thousands, if not tens of thousands of times. You get this bright ring around the foreground galaxy. And that's kind of what you would see with the solar gravitational lens, except the sun is essentially a perfect looking sphere. And so while the galaxy cluster is this weird blobby thing made up of a whole bunch of different galaxies all orbiting around each other, the sun is this sort of sphere. And so you would see an Einstein ring around the sun of the thing that is being lensed. But will you only see objects that are directly behind the sun? Yes, you have to have lined up your telescope perfectly with the thing that you're trying to observe. So it can't be off by any amount. And so that's why the solar gravitational lens mission, when it finally does launch, and it had better launch, it will only be able to have one target, that it will fly past the sun, or fly on the sort of, on the opposite side of the sun at the solar gravitational lens. And it has to stay in this tiny little cone as it moves farther and farther away from the sun. And as long as it stays in that little cone, then it will be able to use the sun as a telescope to see one target, one planet, for example, one exoplanet, is all that the solar gravitational lens will see. And there's like an infinite number of things that you could use the sun to lens. You just have to put an infinite number of spacecraft at different locations, and they're all using the solar gravitational lens to observe them. Drew D2. How old is the universe if you include the pre-Big Bang? So the post-Big Bang is 13.8 billion years. So we know that the universe has been around for 13.8 billion years. And that is the start point. But pre-Big Bang, we have no idea. So there's like one school of thought that time itself is one of the things that was formed at the Big Bang. And so what does it mean to have time before time? So you might say, well, it's a meaningless question, and therefore the Big Bang has been around for 13.8 billion years. But that's not the only answer, right? There are ideas that this universe began from a previous universe. And so pre-Big Bang, you would essentially be including the time in the previous universe. And maybe that universe was formed in a previous universe. So you want to include that time in the previous universe. And so we don't know. And we may never know. We can imagine scenarios in our universe that you could have another Big Bang spontaneously appearing. That, there's this idea in quantum mechanics that particles can appear randomly, and given enough time, an almost infinite amount of time, that you will have essentially all of the particles for another Big Bang appear in one location, and you just get a new Big Bang. And so you could have all of the time of the one universe, and then you would have all of the time of the next universe. And it's a really fascinating sort of philosophical question, because obviously you'd have to keep going back through the universes, but it had to start somewhere, right? Like, it comes back to that same question. Why is there something and not nothing? What was the first? Like, if there was a universe before our universe, and a universe before that universe, and a universe before that universe, what was the first universe and why? Right? Like, why do we exist at all? What would cause a universe to appear? In what? So the sad, frustrating thing is that we may never know the answer to this, that all evidence of what the conditions that led to the Big Bang are gone, that they are obscured by the Big Bang, obscured by inflation. And so we may just never know what came before the Big Bang. Or maybe there's some kind of echo in the universe, that there's some thing that we can tease out that is a hint of what came before the Big Bang. Or maybe the evolution of the universe, once we truly understand what the future evolution of the universe is going to look like, leads you inexorably to another Big Bang. And you say, okay, then that probably happened before to give us the universe. And so then it's a cycle. But cycles have to start at some point. So we don't know. Wayne R777able. What type of proliferation of life would need to be present on Europa for the Europa Clipper to make a positive confirmation of discovery? So the Europa Clipper isn't designed specifically to detect the presence of life on Europa. And, its job is to map the surface of Europa, to search for geysers on Europa, and specifically to measure the depth of the ice under the surface of Europa. Try and find pockets of water deep down. When does the ice end? If there is a subsurface ocean, when does that ocean begin? And Europa Clipper has the tools to be able to do that, to measure the magnetosphere, understand its interactions with Jupiter. But there are a couple of ideas that would get you some kind of stronger proof that there is life. One is the presence of various chemicals on the surface of Europa. And actually, we saw some evidence of this from the Galileo spacecraft that stopped operating, 2003? Anyway, so the Galileo spacecraft went to Jupiter, and it was able to image the surface of Europa and gave us a lot of the sort of modern thinking, showed us the sort of very complex surface of Europa that seems very fresh. We don't see a lot of impact craters on Europa. And recently, astronomers detected the presence of various chemicals that on the surface of Europa that could go hand in hand with life, organic molecules. They don't necessarily mean life. We see organic molecules everywhere. But that there is some kind of process that is making them fresh on the surface of Europa. That these chemicals should be blasted away by the radiation of space, and therefore, if you see them on the surface, then it has to be relatively fresh. The even better thing would be if Europa has geysers in the same way that Enceladus has geysers. Now, there's no evidence of this that we know of today. There's hints of geysers on Europa, but nobody has actually seen them. But if there are geysers, then we would probably see Europa Clipper. If there are geysers on Europa, then we would probably see Europa Clipper doing the same thing that Cassini did with Enceladus, which is that it would fly through the plumes. And then astronomers would be looking for specific kinds of chemicals in the plumes of Europa. So you'll be looking for not only water coming from down below, you'd be looking for dissolved hydrogen in the water, which is essentially food for bacteria. And then you'd be looking for the kinds of chemicals that are associated with life, organic chemicals, things like that. But Europa Clipper does not have any way to really detect the presence of life beyond, helping them figure out these chemicals are there. But people have proposed missions that would do exactly what you're talking about. More to Enceladus, though, not to Europa. So people are proposing a probe that would go to Europa. No, people are proposing a spacecraft that would fly to Enceladus, would fly through the plumes at Enceladus, and would collect samples of the plumes, and then would have a lab on board the spacecraft that would digest the samples and search for any kind of evidence of life. And you might not find life can come in all kinds of different ways. And so this is a sort of an ongoing discussion among astrobiologists, is what is a good agnostic way of detecting the presence of life? How do you know life when you see it? Especially, how do you know life that isn't anything like Earth life? Like, what if it doesn't use DNA and RNA? Like, all of our labs are designed to search for those kinds of things. And so it appears to be, it's in the complexity of the chemicals that life tends to produce more complicated chemicals than non-life. And so if you flew through the plumes at Enceladus with your spacecraft, you then sort of examined all the chemicals that were found in this. If you seem to have a lot of complicated chemicals, that is a good indication that life is producing this, as opposed to, volcanoes or geothermal vents under the surface on Enceladus. So we're still a long way. And really, to get to Enceladus, to actually see if there's life on Europa, you want to go under the ice. And that's going to require sinking down through the ice, melting through 10 kilometers plus of ice down into the ocean underneath. And then you swim around inside that and look for the European space whales. Science compliance. If we discovered extraterrestrial life, how would you celebrate the occasion? So it's interesting. I always think about the Arthur C. Clarke quote, right? Either we're alone in the universe or we're not. Either possibility is equally terrifying. That if we are alone in the universe, then that sucks, because then it's up to us to spread life into the cosmos. And, we have demonstrated that we can be mean to each other, and we are always just a few steps away, a few ticks of the clock, the doomsday clock, away from nuclear Armageddon. So do we have the wisdom and cleverness to pull this off? I don't know. But if we are in a vastly populated universe with life everywhere and a lot of competing intelligences for the limited resources of the Milky Way, well, that could be a problem for us. But there is another idea that you want to think about, and that is the Great Filter. So, one of the possible answers for the Fermi paradox. Okay, so the Great Filter is this idea that's proposed by Robin Hanson. And this is an answer to the Fermi paradox. The Fermi paradox, of course, is the universe is big and it's old and the conditions for life are everywhere. And so life should be everywhere, but we don't see it. So where is it? And the Great Filter says, well, there are a bunch of filters that you have to get through. You have to have abiogenesis. You have to make life from non-life. You have to develop single-celled organisms. You have to create multicellular organisms. You have to create intelligence. You have to create technology. And then you have to create spacefaring. And then you have to go to other star systems. And that is like the chain of events. And each one of those steps is a filter that filters out the life on some world. And then in theory, here we are here on Earth. We've gotten through all of the filters. We've gotten through the abiogenesis. We got through the single life. We got through the multi-life. We got through technology. We got through spaceflight. Next, really, all that's left is for us to go interstellar. And in theory, hopefully, the great filters are behind us. We have completed them. But maybe there is a great filter in our future. And so sort of one of these ideas is that if we find life is very common out there in the universe, but advanced life, communicating life, spacefaring life is non-existent, then we would assume that the Great Filter is in front of us, because we found life on Mars and it's totally separate from us. And we find life on Europa and it's totally separate from us. And we find life on Proxima Centauri and Alpha Centauri, and they're all totally, they formed completely independently, and yet we don't see any evidence of an advanced civilization. Then that means that the filters, there are still filters in the future, and they could be nuclear war, and they could be asteroid strikes, and they could be everybody just decides they want to live in simulations, and they could be the rise of the AI. Who knows? And so if we find life on other worlds and we find more and more of it, and we don't find any intelligent life, then we should start to be scared, because it means that the Great Filter, whatever it is that has stopped other civilizations from going interstellar, from communicating with other star systems, whatever stopped them is about to stop us. So if we found extraterrestrial life, my instinct, my natural enthusiasm would be like, woohoo, right? I'd be so excited. And I would not shut up about it here on the channel. Like, obviously the way I would celebrate it is I would be wall-to-wall coverage explaining it here on YouTube and on Universe Today, and we wouldn't shut up about it. That's how we would celebrate it. But personally, I would be starting to feel nervous when I think about the Great Filter and wonder if there's a Great Filter in front of us now, because we have found life. The closer to home that we find life, the more we should be nervous about the Great Filter. James McIntosh, can creating a man-made magnetosphere on Mars make Mars hold an atmosphere better? Yeah, absolutely. If we could generate a magnetosphere for the entire planet Mars, then it would no longer be losing its atmosphere to space, because essentially it lacks a magnetosphere. The solar wind is buffeting the planet and pulling particles of its atmosphere out into space. It has a tail in space from the atmosphere that is being blown away by the solar wind, while the Earth is protected by our magnetosphere. And so the sun is limited at how much of our atmosphere it can tear away. Although we lose about 100 tons a day, but it'll last longer than the age of the sun. Venus has a tail as well. But if we could create a global magnetosphere, then we could stop that loss of atmosphere. And then actually natural just release of volcanic gases coming out of Mars would start to thicken the atmosphere naturally. Like, it's just that there's more atmosphere that's being lost than is being replenished by this outgassing. So create a magnetosphere, block the solar wind, the atmosphere would thicken up, and you would actually get melting water. And you would get, theoretically, you could start to walk around eventually on Mars without a pressure suit, which would be pretty cool. Now, that all sounds great, right? So you're like, how do we start a global magnetosphere? Well, we don't. That what's required to get a global magnetosphere is to have a dynamo, to have a rotating core at the center of Mars, and it just doesn't have that. It's cooled down. It's too small. Only has 10% of the mass of the Earth, so it's tiny, and so it cooled down more quickly than Earth, and its dynamo shut down about 3.5 billion years ago. But could we just build something on the surface? Like, let's build some kind of, series of wires on the surface of Mars and generate the magnetosphere. And still, that's just like, it's a level of engineering that we can scarcely comprehend. And why would we do that when we have Earth, right? The one idea that I do like is that you could put a solar sail, some big thing, at the Mars-Sun L1 Lagrange point, which is kind of like this balance point between Mars and the sun. And that if you put this thing there, you could have it cast shadow on Mars, blocking the solar wind from impacting Mars. And you would sort of balance this thing so that the solar wind that's hitting the sail is is keeping it in position, and you would sort of turn it a little bit and turn it a little bit as the solar wind is impacting the solar sail, and it would remain in position. And so none of those particles would reach Mars. And so that would be an easier way to be able to do that. It would still be incredibly complicated and difficult. And then that would stop the solar wind part, but it wouldn't stop the radiation that's hitting the surface of Mars from cosmic rays and things like that. So this is going to require technology, the levels of which we just can't even imagine. Wow. Why are we so certain that we need a moon around a planet to create life? Can't there be aliens that are so alien-like that they were born on their planets far away in some other mysterious way? I don't think anyone says that we absolutely need a moon to be able to have life on a planet. There are proposed many ways that having a large moon around the Earth has helped out the evolution of life on our planet. I'll give you a couple examples. One is that it creates stability for the axial tilt of the Earth. And so Mars, it looks like, has rolled over in the past. There's evidence that the whole planet has rolled around. And we look at Venus. Venus has no moon, and it is 177 degrees. It is upside down, rotating backwards compared to all of the other planets. Earth has this large moon that acts like a stability and keeps our axial tilt within a very tight range, which is good, but that's not a death blow to life, right? It just means life has a harder time. The other thing is that having a large moon creates tides, and the tides create this intertidal zone where the water goes in and the water goes out. And when the water is in, then you've got life forms that were sitting in that tidal area that have to evolve to be able to handle varying amounts of being out in without air, or out in the air, right? Outside of the water. And it's a sort of a really smooth way for them to be able to evolve from living in the water to living on land. Without a moon, then you wouldn't have tides, but that doesn't feel like it is a total showstopper, that life would find a way. So it appears that a large moon makes a planet more habitable, but not having a large moon doesn't make a planet uninhabitable. Just, moons are better. Big moons are better. 1,000 dots. Wouldn't that cut off heat and light from the sun as well? So if the shadow falls on Mars from this thing, but it doesn't have to be black, like it doesn't have to block the light, it just has to block the solar wind. So one idea is that you would make it a mag sail. So instead of it being like an actual opaque piece of plastic or mylar or something that's floating out there, you would have it be this net that is electrically charged. And so the solar wind particles would be deflected as they go around this sail, this mag sail. And so that wouldn't cast a shadow on Mars. So no, you could build this thing, it would deflect the solar wind, but it wouldn't block the light getting to Mars. Aeroskiff, would it be feasible to hitch a ride on an interstellar object? Is anyone planning for such an event? We get this question quite a bit. So the problem with trying to hitch a ride on an object like a comet or an asteroid or an interstellar object is that in order to land safely on the surface of that object, you have to match the velocity. And once you've matched the velocity, there is no need to hitch a ride. You are going the speed of the thing, because then you just coast. When you look at, say, the planets have been coasting around the sun for 4.5 billion years. And so if you had a spacecraft that wanted to be able to land gently on the surface of an interstellar object, you would have to fire it so that you have to put it on a rocket. The rocket would have to match the velocity of the object, and then you have to land gently on the interstellar object. The hard part is done, right? And so you could also just fly your probe, and it would fly right beside the interstellar object, and they would just remain in formation for billions of years because you were able to match its velocity. So unfortunately, there's sort of no reason, there's no savings in trying to get to an interstellar object. The benefit that you get is that the interstellar object is made of stuff. And so if you want more propellant, you want more raw material for your spacecraft, if it can somehow can dig stuff up on the surface of the object and use it for something, then now you're cooking, because you land on the object, you're now able to study it, deploy rovers, and then maybe even turn its raw material into more rovers or more spacecraft. So there are some good reasons why you'd want to land on an interstellar object as it's making its way out into the universe. Dougal, if the entire supercluster of galaxies that we are a participant of was rotating and we were rotating with it, is there a way that we could tell there's a rotation? Yeah, absolutely. Astronomers can tell the sort of independent movement of the Milky Way in the cosmos. And the way you do that is you measure our movement compared to the cosmic microwave background radiation. And when you do that, you get about, I think it's about 600 kilometers per second or 550 kilometers per second. And so we are moving, and I forget which direction, but we are moving at about 550 kilometers per second with respect to just the cosmic microwave background radiation. And you can also measure the rotation of the various things that we are a part of. We are part of the Virgo supercluster. We're part of the local group. We're part of the Virgo supercluster. We're part of the Laniakea supercluster. And these things are rotating. But it's really important to understand that while these things might be rotating, and they're going to take hundreds of millions, billions of years to fully rotate, that the expansion of the universe is tearing them apart. That really any structure that is bigger than the local group, bigger than about, say, 5 million light years apart, is just going to be pulled away by dark energy into more little groups. So you sort of imagine we are actually bound gravitationally to Andromeda and the Triangulum galaxy and a bunch of dwarf galaxies around us. And in the far, far future, these galaxies will eventually merge together into one giant elliptical galaxy. Although some people argue that Andromeda is actually not going to join us in the local group. But anyway, some combination of galaxies will join into this larger elliptical galaxy. And then the galaxies that are about more than 5 million light years away from us, they are just moving too quickly and they're going to be accelerated by dark energy and they will go away from us. So at a certain point, it no longer makes sense to say things are part of an object. Like, yes, we are gravitationally bound to nearby galaxies, but we are not gravitationally bound to galaxies that are tens of millions of light years away from us. We are gravitationally influenced by them, right? The movement of the Milky Way is changed by the gravity of those other galaxies, but we are not bound to them. And so eventually they will move farther and farther away. They will be hundreds of billions of light years away. They will fall over the cosmic horizon, and there will be no evidence that they ever existed to future astronomers. Hangman 747 Tin Man. What about just using the interstellar object as a shield? Yeah, I mean, if you want your spacecraft to survive, then there's a lot of good things that you can do with an interstellar object. One of the biggest challenges to spacecraft is cosmic rays. And a lot of the reason why spacecraft generally die is because of cosmic rays. And so you're going to want to protect your spacecraft from cosmic rays. And the best way to do that is to dig under the ice. Once you get a meter under the ice, then you are protected from the cosmic rays. So if we wanted to put a spacecraft, bit my tongue. If we wanted to put a spacecraft on an interstellar object and we wanted to survive for long periods of time and not get hit by lots of radiation, we would have it dig down under the surface on an interstellar object, find a cave and go into the cave, and then it would be safe from space radiation. So yeah, there's a bunch of good reasons. It's just we can't take advantage of the velocity of the object to take us places. Amelia Nolaneri. Do you know if the Earth always follows the same path when it travels through on the Milky Way? So the Earth is part of the solar system. The solar system is orbiting around the Milky Way, and it takes about 230 million years for the solar system to complete one orbit around the Milky Way. So you think about that, like the last time the solar system was at this location, the dinosaurs walked the Earth, and not like the late dinosaurs, not the Jurassic dinosaurs, but earlier versions of the dinosaurs. And then the previous time before that, like multicellular life had just gotten started. So it takes a long time for the solar system to orbit around. And you can do the math, and really the solar system has only existed for like less than 20 Milky Way orbits. Is that right? Let me just do the math now. I feel like 17 is the number, but let me just get the number. So 4.3 billion divided by 230 million, 18. Okay. And so if you do the math, go back to there. And so if you do the math, the solar system has only orbited less than 20 times around the Milky Way since the formation of the sun. But the question you asked is it always taking the same path? And when we think about like the solar system, and the planets are following essentially the same paths around the sun as they orbit around. Now, it's not exactly the same, because the actual orbits around the sun for the various planets are slowly shifting. So if you think about it, the planets are on elliptical orbits, and the part where they get to their closest point of the sun, the part where they get to their farthest point of the sun, is kind of like slowly turning around. The planet's going around and around and around, but the shape of its orbit is slowly just sort of rotating around the sun. And that's caused by the interactions between all the different planets, mostly Jupiter. But the motions of the stars around the Milky Way are not like that. They are roughly going around the Milky Way. So the solar system is taking a journey around the Milky Way, but there's just so many interactions between all the different star systems that the sun are going to pull the sun back and forth along its journey. And so if you sort of looked at it, it would be sort of doing this wavy journey around the Milky Way before it returned roughly back to its starting point. And that, stars that had begun that journey have died, and stars that were just clouds of gas have become full stars. So the actual Milky Way at the scale that the solar system is moving around the galaxy is so dynamic that you're just not going to get this sort of perfect following the path in the same way that you get with the planets. R. Warren, couldn't we use the entire moon as a data center? Possibly. So, we're entering this age where people are starting to wonder, what could we build on the moon made from the moon? The Chinese with their Chang'e 8, Chang'e 7, Chang'e 8. The Chinese with their Chang'e 8 mission are going to be testing out in situ resource utilization. So they're going to land a lander on the surface of the moon. They're going to ingest a bunch of regolith on the surface of the moon. They're going to mix it with some other binding agent, and they're going to start to create 3D items on the moon. And this is just a test. Can you build little wrenches on the moon out of regolith? But later on, people will be using larger 3D printers to actually make stuff on the moon. And so you can imagine this time where we are creating, say, solar panels on the surface of the moon purely out of the material that is found on the moon. There's a type of solar panel called a perovskite, and they're much easier to manufacture. On Earth, the downside is that they are sort of destroyed by the oxygen in the atmosphere, but there is no oxygen on the surface of the moon. And so you can make these perovskite solar panels on the moon out of local material. And so you can imagine there would eventually be rovers that are moving along the surface of the moon, and they are digging up regolith, and then they are baking them and putting them in a kiln and simplifying them and extracting the metals and creating glass and making perovskite solar panels, and then laying them out in this sort of trail, this poop trail of solar panels behind the rover. And the thing is powered by sunlight and just drives along and just makes solar panels as it goes. You can kind of imagine that sort of future. And so if it turns out that building data centers on the moon is a good idea, and there are sort of pros and cons. The con is that it's on the moon and it's very expensive and very difficult to get to the moon. But if we can set up some kind of, robot factory that builds this stuff, well, then maybe that actually makes a lot of sense. It has no atmosphere. It's exposed to sunlight for half of the time. There are places that are almost in full sunlight near the poles of the moon. There are places that are in eternal shadow that would handle cooling really well. So you can imagine you'd have a data center that sits on the top of a mountain on the moon, and then it has its cooling system down in the eternally shadowed craters. And so it's able to shed all of the waste heat and be able to run its computing. And then over time, who knows what's going to happen? Then we just turn more and more of the moon into computing. There's this idea of was it Matryoshka brains? But essentially that, we can see some future where the most efficient thing for computing is to come up with something called computronium, that you build whatever is the most sort of efficient 3D computer. And then you just turn whatever this computer requires. Silicon requires aluminum, titanium, oxygen, whatever it requires. That material is all available on the moon. And so you can just slowly turn more and more of the moon into computronium. And you turn more and more of the moon into a giant computer cluster. So it is theoretically possible. There's nothing special about what the moon is made out of. It's just hard for us to sort of imagine doing and under our current technology. I see people were mentioning that they got ads at the beginning. Yeah, we have no way to turn off ads at the beginnings of our videos, but hopefully you didn't get any ads in the middle of this video. Please let me know. If you get ads in the middle of this video, we have purposefully turned all that off. But I am waiting. I'm just assuming that YouTube is going to start forcing mid-roll ads. It feels like it's natural. They know whatever is the best mid-roll ad, the best performing, the one that minimizes the chances of people dropping off. Some people tend to abuse the mid-roll ads. Other people, like us, don't put any in, and we're just leaving money on the table. YouTube is constantly reminding me that I'm leaving money on the table by not putting in mid-roll ads. But please let me know. Charles Monton saying, Fraser would probably enjoy 3D printing. It'll take time to learn modeling and slicing, but I can see him enjoying the fruits of his learning adventures in 3D. I would love to get into 3D printing. I actually bought my wife a 3D printer a couple of years ago because I thought she would be into it. and we were a little early in on the game. I got a micro. Oh, I forget the name of it. It was a cool little 3D printer, but it was still just a total pain. It was very unreliable to get the thing to actually print. And so we did a couple of prints, and she wasn't into it. She didn't like it very much. And so we ended up selling it, which was too bad. But it was like the technology was really early. Like I think I bought it like 10 years ago. So I've been looking at the new kinds of 3D printers. There's like these resin printers that are really cool. And like, I would love to 3D print figures for the role-playing games that we play. You know, I run this Dungeons and Dragons game for my kids, and I would love to get figures and we can paint. You know, I've mentioned this, right? My secret history is that I used to work at Games Workshop. So I used to paint figures for a living at Games Workshop and teach people how to paint miniatures in Vancouver. And so I'd love to do that. And you could just 3D print enough monsters for your campaigns. It'd be great. I love it. So yeah, I would totally be into 3D printing. And in fact, I'm doing a lot of weird projects. So I'm working on controlling a telescope directly. And so I've got like a Raspberry Pi, and I've got a breadboard, and I've got a bunch of controllers and stepper motors, and I'm trying to control this telescope's motors. And I've got this sort of Frankenstein breadboard with wires coming out of it. And I would love to 3D print a case for it so that it's all nice and organized, as opposed to, I don't know, putting it in a plastic box or something. So yeah, I would love to get a 3D printer. If you have recommendations, please let me know the best 3D printer, the one that doesn't suck. Okay. So that's the printer that I want. It's the one that doesn't suck. Charles is wanting to sing, I get banner ads covering the chat window. Weird. Okay. Yikes. Huh. So the chat window is popping up an ad. I don't like that. Yeah. Gangster Daddy, do Type 1a supernova destroy their companion? So a Type 1a supernova is a cataclysmic variable star. We actually covered cataclysmic variables in Astronomy Cast this week, and they're a class of star where you have a star that is feeding off of a companion, a white dwarf that is feeding off of a companion star. And when it reaches a certain point, the thing detonates as a supernova. And that was an overly simplified version of how you get a Type 1a supernova, because there's like a bunch of things that are much more complicated about it. But anyway, so what happens to the partner star? Well, there's a couple of ideas. The one is that you essentially, that's how you get stars that are on escape trajectories out of the Milky Way. That you have this white dwarf and you have this star, and they're orbiting around each other, and the white dwarf is causing this star to move very quickly in a orbit around it, and then the white dwarf disappears, and so now the star is thrown out like a slingshot, and theoretically that could make it move fast enough to be able to escape the Milky Way. So that's one possible explanation. So when we see these hypervelocity stars, they are the result of their partner exploding as a supernova. Smoke. Do we know whether space expands uniformly? So astronomers hold to this thing called the astronomers hold to this idea called the Copernican principle. And the gist of it is that you're not special. That we live on a planet that is in a star system, that is in a galaxy, that is in a cluster, that is in a certain part of the universe. And at the largest scales, the rest of the universe is kind of the same. You can go to some random place in the universe and you will see around you galaxies and planets and moons and stars. They won't be the same moons and stars and clouds of gas and tentacled aliens, but they will be sort of roughly, it'll rhyme, right? And so one of the assumptions is that the things that we're seeing happening around us, the forces of gravity, the forces that are accelerating the expansion of the universe, the power of light, these are all the same. And so this is a question that astronomers have wondered, which is that, is one way that you can explain the crisis in cosmology, the Hubble tension, that it seems like the expansion of the universe is different depending on the distances in the universe, maybe that in fact the expansion of the universe is uneven. But there's been no evidence to show that all of the tests that have been done seem to show that the sort of, when it comes to space, the expansion appears to be even. What appears to be uneven is time. So at different times in the history of the universe, the expansion has been at different rates, potentially. The one possibility is that dark energy is a completely constant. For every extra cubic meter of space that you get an equivalent amount of dark energy, right? But another possibility is that dark energy is changing over time. And so early on in the universe, you had less dark energy or more dark energy, and that amount has been decreasing. So a cubic meter doesn't produce you the same amount of dark energy today that as it did in the past. And so when you go to different spots in the universe, everything would look like it was expanding uniformly around you. But at different times in the universe, then the expansion might appear to be different. Oh, I didn't put this up. Oops. Sorry, Chad. Jonathan Chamberlain. Jonathan Chamberlain, is the vastness of space and the unknown nature ever unnerving for you? I love space content, but sometimes it gives me major anxiety. It's interesting. I've seen people say this often. I look in YouTube comments, and when you look in Reddit, often like at r/space, there will be some comment that is like that, where someone will say, do you ever just sort of feel nervous and scared about the universe? And I don't at all, and never have. And so maybe that's why I'm so excited about it, and that's why I turned it into my job. But no, I don't feel any kind of existential dread about the universe. I feel curiosity. I feel kind of excited about the unknown and the things that we're going to discover. And there is kind of a sense of this that I totally get, which is, I always mention to people that we have less time for the Earth than we thought, that the sun has been around for 4.5 billion years. It's probably going to start expanding and becoming a red giant in about 5.5 billion years from now. And so you'd think, okay, we've got 5.5 billion years. Like, that sucks, right? But of course, none of us have more than about 100 years, right? So why do we even care about 5.5 billion years? And then you say, well, actually, the sun is expanding, or the sun is heating up, and the amount of radiation that's falling on the Earth is increasing, and that is going to raise the temperature of the Earth over the next billion years or so. And it's going to raise it to the point that the oceans boil. And so the Earth doesn't have 5.5 billion years. The Earth actually only has about 1 billion years. And now, we thought we had 5 billion years. Now we only have 1 billion years. We feel sad, right? And that's a weird feeling, but I totally get it. And then you think about the other hard limits in the universe, like maybe there's this idea of the big rip that the amount of dark energy that's coming into the universe is increasing, and that per cubic meter amount of dark energy, maybe that number is going up. And if it does, then maybe the entire universe is going to tear itself apart at a atomic level in about 10 billion years. And like you thought we had trillions of years, but maybe we only have 10 billion years and we'll go out in this really awful way. And so now you're like, oh, I feel sad. But even if that doesn't happen and the heat death of the universe is what we face, right? That in all of the stars will run out. All of the stars will get kicked out of their galaxies. When you think about like the entire Milky Way will shed its stars one by one. It's dead stars, right? It's black dwarfs. After all of the stars die, they all cool down to the background temperature of the universe. There'll still be a galaxy made of all these dead stars, but then just gravitational interactions will kick out the stars one by one until they're all gone, until all that's left of the Milky Way is the supermassive black hole at the heart of the Milky Way. And then that supermassive black hole will evaporate, and it'll take 10 to the power of 100 years before it finally evaporates all of its particles. And so the universe will be cold and dead. There will be no more heat to be able to do any useful work in the universe. That is the heat death, right? It's not the death by heat, it's the death of heat. And it makes you feel a little sad. Even though the numbers are incomprehensible, that, even if you could live effectively forever, you are going to have an accident in your spacecraft. You're going to have a warp core breach and you're going to die in the next, million years or so. Like, there's just no way you can avoid this. That just random chance will eventually take you out unless you live in a computer, right? And we feel this because I think we lack context. We have no way, like we know we're going to die. And when you really think about it, you are horrified. And so we don't think about it. Like, don't think about our own death. Don't want to think about that. But if you do think about it, you get horrified. And so there's things that have shades of us dying. The death of the Earth, the death of the solar system, the death of the galaxy, the death of the universe. And it triggers those same feelings. And my guess is that the experience that you have about looking out into the cosmos and thinking about infinity is like that same experience that you have. Like, imagine you're in an ocean at night swimming. You've jumped out of the side, you've stopped your cruise ship above the Marianas Trench. You've got 10 plus kilometers of ocean or whatever it is below you. And you hop out into the ocean and it's at night and they turn on all the lights on the cruise ship and you're just paddling around in the middle of the ocean in the darkness with all of this sea below you and sky above you. And you feel a little unnerved, even though it's probably totally safe, right? There's no sharks out there in the middle of the ocean. Nothing's going to bother you. You float. You know how to swim. Doesn't matter how much water is underneath you. Doesn't matter how much air is above you. You swim, but you feel a little unnerved. And so I think that's the feeling, this idea of infinity in time, infinity in space. Those are unnerving thoughts. And so I don't have them. Like, for me, it doesn't trigger that. But I get it. I can kind of imagine what it would feel like. So I don't know if I put I don't know if that was, Jonathan, I don't know if that's what you're going for or if that's some version of that. Please let me know. But that's, for me, I don't feel any of that. Like maybe I'm a monster. Maybe but I'm so excited. And maybe it comes from knowledge. Maybe it's just like the more you understand it, the more you just see that it's all just gravity. In the same way, the more, that you understand that you're perfectly safe floating in the middle of the Pacific Ocean in the darkness. You're just floating. You don't swim. You're fine. Boat's over there. Just enjoy your swim, your night swim, go over there. I understand how gravity works. I understand the motions of things, the time scales of things, how stars work. Like none of that feels like it feels appropriately mysterious, not terrifyingly mysterious, not eldritch horror, ennui mysterious. $1,000. Is there any chance anything remotely alien related will come out of releasing the UFO files? So at the time that I'm recording this, we had a bunch of interesting revelations come out. The first one came from an interview with what was his name? Anyway, an interview with Barack Obama, where the interviewer asked him, he's gonna kill me. I should know his name. Hold on. This is awful. I should name check him. Because he got the scoop. Hold on. Oh, the YouTube search is so bad. So I'm searching YouTube and I said Barack Obama, and now it's Barack Obama UFOs, and now I'm in Barack Obama UFOs, but that's probably not connected, right? Oh, someone's going to say, all right, Brian Tyler Cohen. Okay, that's it. It was Brian Tyler Cohen. Yeah, okay. All right. So the time that I'm recording this, Brian Tyler Cohen, about a week ago, asked Barack Obama if aliens were real as a kind of, one second here. Look at the camera. Okay. About a week ago, Brian Tyler Cohen asked Barack Obama whether UFOs were real. And it was just like a throwaway question, just for fun. And Obama said that he thought they were real. And he later clarified that, in fact, what he meant was he believes in aliens in the way that most people do, that they feel like the universe is big and the universe is old and life should be everywhere, and therefore there should be aliens out there. And people thought this was confirmation, like, because of the president of the United States, if anyone knew, it would be the president of the United States. And he clarified that he had no direct evidence, no way to know, but he sort of felt that there were aliens out there. And then we got an announcement from Trump that they were going to disclose information about UFOs. And so now the UFO community is excited because finally presidents are going to reveal the evidence of the UFOs. I am skeptical, right? As usual. Which is that, like, people have been asking me what's going to happen with the UFO disclosure now for the entire duration of my career. What am I at now? 27 years? The UFO disclosure any day now, right? We're going to have committee hearings. It's going to happen. It has yet to happen because so far there has just been no concrete evidence of the existence of aliens. And until someone actually supplies it, then nobody has anything to study. So if my experience holds true, this time around will be exactly like all the other times around, which is that there will be no evidence will be presented. Nobody will be able to study anything. They will have no conclusive evidence that there are aliens that have been visiting Earth and that our scientists have any knowledge of this. That is my anticipation for what's going to happen. I can't wait to be wrong. Like, just to be clear, I want to be super wrong. I want you to hold me accountable, to say, ha, Fraser, you said that there wasn't going to be any, firm evidence of aliens. And yet Trump rolled out the alien corpse and the scientists fell upon it like a pack of hyenas, studying it to the nth degree and made all of these proclamations that aliens are real. I will be so glad to be super wrong about that. But I anticipate that I will not be. I anticipate that it will be, that nothing will come of this. There will be no evidence. And it is not a political thing. I don't care who said it, right? If it was Biden saying this, I would anticipate the exact same thing. And, whoever comes next, that like someone needs to put up or shut up. Let's see some aliens. Not talk about aliens. Let's see actual aliens. Let's see spacecraft, alien spacecraft, and put them in the hands of scientists. Let's see some peer-reviewed journals publishing articles about the study of the aliens, the confirmation of the aliens. Hangman Tin Man. Even at the heat death of the universe, would systems like Jupiter and its moon Io still exist, and their gravity interactions still generate heat? So eventually, like when you think about the heat that's being generated on Io, it's a gravitational interaction between Jupiter and Io and the other Europan moons. And so over time, like vast periods of time, all of the sort of the orbital differences between all of the moons around Jupiter will eventually even out. That they will end up in a way that they're no longer causing these resonances with each other, and they will no longer cause these perturbations that is leading to the tidal flexing that's happening with Io. Even that will settle down over vast periods of time. And then in addition, the gravitational interactions will peel away the moons from Jupiter one at a time. Interactions with Saturn, their orbits will get farther, their interactions will get more complicated, moons will be peeled away, and eventually even Jupiter will no longer have moons. And then the sun will have no planets. Like, I think it's like a 5 trillion years, all of the planets will be stripped away from the white dwarf that was once the sun, just through interactions with the Milky Way. And that over, hundreds of trillions of years, all of the stars in the galaxy will be stripped away. So just nothing can hold over long periods of time. Potato Biden, are there multiple dark matters and dark energies? Almost certainly. We talk about dark matter as if it's this one thing. That there is the answer to the dark matter observations. And once we know what that thing is, then it will clear them all up. But when you talk to most astronomers, they're pretty sure it's going to be a collection of solutions. Like there's going to be this amount of this particle, that amount of that particle. We didn't understand gravity, and there's also primordial black holes. And collectively, those explain the dark matter observations. And we have new theories, right? All bundled together. Same thing with dark energy. So generally, these things are more complicated than what you think sort of going into it. Granby, are Pink Floyd still on the dark side of the moon? I think so. Domingo Flav, do solar systems have Lagrange points? So I don't 100% understand the question, because are you saying like, do solar systems have Lagrange points with each other? Because, other star systems are going to have Lagrange points. Like the TRAPPIST-1 system is going to have Lagrange points. Wherever you have two objects that are of very different mass by about 25 times more. So a star and a planet and a moon. You're going to get Lagrange points, the same 5 Lagrange points. Like there is 5 Lagrange points between the sun and Mercury, 5 between the sun and Venus, 5 between the sun and the earth. There are 5 between the earth and the moon, 5 between Jupiter and the sun, always 5. And so there are going to be 5 among, a star and their planets, or those planets and their moons. But are there Lagrange points between star systems? And then the answer is no. You need to have something that is very massive and then something that is not very massive. That's when you get the Lagrange points. So star systems are roughly equivalent in mass. So they won't create Lagrange points. And they're not in orbit around each other. They are orbiting around the Milky Way. And so their distances are changing. I like turtles. Do people ever confuse you with Kelsey Grammer? So his name on the show is frasercain, and my name is frasercain. And so I have the good Canadian accent version, the Canadian pronunciation. Or I guess it's the Scottish version, really. I was born in 1971. The television show Cheers premiered in 1981. So I had the name for 10 years. And I don't even know what year Frasier was introduced on Cheers, but it wasn't the first season. It was like 2 or 3 seasons in. So let me see. Let's see. Frasier, first episode, Cheers. 84. Episode 301, September 27th, 1984. So let's assume that the showrunners for Cheers came up with the idea of the character when they were writing the script sometime in early 84, maybe 1983. I think we could be safe with 1983. So in 1983, I was 12 years old. I had had the name exclusively for 12 years. And then some dummy who wrote the Cheers TV show, I didn't even come up with the person's name, who wrote Rebound Part 1. Let's find out who this person is. Rebound Part 1, Episode 1, Cheers. Okay, let's find out who wrote it. Glenn Charles and Les Charles, which were sort of the writers of this. So, are they still alive? Glenn Charles and Les Charles. They're in their 80s right now. So I probably can talk to them and get them to apologize. I should do that. Because I've tweeted at Kelsey Grammer and asked him to please just relinquish the name. Your show bombed the second time around. So it's over. I get my name back now. Right? You guys took your shot. You had your show. You had your chance. You had your run. It was fun. But you borrowed my name for 40 years. And it's time to give it back. So I think that's what we're going to do. So, but obviously I should have sued them day one as a 12-year-old, because, if you don't defend your copyright, then possession is 9/10 of the law. So I kind of messed up by not getting a lawyer the moment I saw that show. And so wait a minute, this guy's name is my name. Dad, who's our lawyer? That's what I should have said on Hornby. Growing up, living in the country of rural Canada, suing. What show were they on? What Cheers? Then ABC, what were they on? NBC? I don't know. Who cares? Paramount? It's on Apple TV. I could probably write in to have them I could threaten Apple to not show Cheers on their channel. Maybe that would work. So, yeah. There you go. I had the name first. So, for the longest time, when I used to be in the business world, when I was software developer, I would have to make phone calls to executives in the United States. I'm like, hi, my name's Fraser Cain. Like, your name is Fraser. It's like Frasier, like the show. I'm like, yes, I have the same name as the guy in the show. I'm aware of this. No, but like, seriously, man, your name is like the guy in the show. Like, yeah, I know. I'm aware. But recently there was like the cleaners who were working on our house when we moved out of our place. And she was asking for my name. I said, my name is Fraser Cain. It's kind of like this show, the guy from Frasier. And she just looked at me blankly and she's like, well, I don't understand. There's this show called Cheers. And then there's this character called Frasier. And she's like, I don't know what you're talking about. I'm like, yes, I got my name back. And then they renewed the show recently and it bombed. So everything's fine. I won't watch it. Mostly because they stole my name. And I'm not bitter at all. All right. We've reached the end of our episode. Thank you, everybody, for hanging out with me on this Monday night. Thanks. A huge thank you, as always, to Zapfan and the rest of the moderators. Zapfan and the moderators, which is, I believe, our band. What's happening? Question show tomorrow. Question show Thursday. I got 3 interviews this week, and they're good ones. But we'll be trickling them out next week. Who am I interviewing? Interview. Oh, no, that's next month. Next week, actually. Okay. Yeah, all right. So March 3rd, I'm doing a killer interview. It's going to be so much fun. But I can't even tell you who it is yet. So I've got on Thursday, I'm interviewing Casey Hammer, who's one of my favorite people to talk to. And we're going to be talking about Elon Musk's plans to put data centers in space. And then I've got, tons of interviews. It's going to be a lot of fun. I've been a little interview crazy. So there's that. New episodes of Astronomy Cast. And the next live stream is going to be on Sunday night at 10 p.m. my time, which is my sleepy time, but I'll do my best. All right. Thanks, everyone. I appreciate it. And I really enjoyed this. The new system seems to work. No bugs. I got through almost every single question that you guys asked me. So I got through answered 32 questions. And I think there's 13 that I didn't get to, but wait, not that one. That's not a question. That's not a question. Not that one. Not that one. So maybe like 6 questions that I didn't get to. So that was great. That felt like very productive. So I hope you all enjoyed it. All right. We'll see you all next time.